Today we're going to be walking through a simple example of the time travel debugger for the Elm language. As you can see here, we have already downloaded the source code for the to-do example project, which can be found at the link in the description below. We will step through the process to show how the time travel debugger is enabled and utilized. The first step is to cd into the directory containing your Elm project and run elm make on the file you are compiling. Upon successful compilation, you can then open the index.html file located within the root directory of the project. This tutorial example allows a user to create a to-do list of items and then cross them out or delete them when they are no longer needed. Let's stop here and set up a scenario. As a developer, you've sent the web page to a tester in your organization and they have discovered a problem. In this example, the web page is simple and it's easy for the tester to relay what happened when the problem occurred. But if you had a complex web service that only presented the problem under very specific circumstances, recreating the bug or even finding it would be a daunting task. That's where time travel debugging comes in, and the way in which Elm relies on messages and updates to models makes this easy. So let's pretend we're the tester and try to find a bug in the page. First thing we want to do is start debug mode. To do that, we run another elm make command with a debug flag set. Now we will reload our page and take note of the new tool in the bottom right of the window. This is the time travel debugger in action. What makes this special is that it tracks every change that occurs on the page and logs it to a file, so a developer can come back in and recreate the exact circumstances that led to a particular bug. Let's explore what happens when we interact with the page. So far so good. It looks to be performing as expected, but what happens if there's an error? It's not my responsibility as a tester to figure out why something is broken. I only report findings. So I export my history and send it back to the developer with some documentation as required by the organization. So now we're back to the developer, and I don't want to bother reading the technical document about what happened, so I'll import the tester's history and see what happened for myself. With this, I can move step by step through the updates to a model and see exactly what went wrong and when. I no longer rely on the tester to fully describe the error and can gain more insight into where the problem or code logic error may be. So in a nutshell, that's the basics of Elm's time travel debugging tool.